Welcome. So in this session, we are going to discuss how to pick the correct forms of particular solution when solving differential equations by method of undetermined coefficients. So the problem is determine the form of particular solution for the following differential equations. So the first example is y double prime minus 5y prime plus 6y equals to 13. So the key thing that we need to remember in this is that in this case, we are trying to solve equations of this form. So the particular solution yp is governed by the structure or the form of g of x. So for our case, because g of x here, these are constant, then the correct form of yp is simply a constant, say a. And number two, if we have y double prime plus 4y prime minus 2y equals to 2x squared minus 3x plus 16, then what determines the form of the particular solution is this g of x, and this being quadratic, then the correct form of particular solution yp will be given by ax squared plus bx plus c. If we have y double prime plus 4y prime minus 2y equals to, say, 2x squared plus, say, 10. Still, this g of x is quadratic. So the correct form of yp of x remains to be the same, ax squared plus bx plus c, despite the fact that there's no term with x, but this is what defines the nature of the function being quadratic. So therefore, you have to take the full structure of a quadratic polynomial. Even if we have y double prime plus 4y prime minus 2y equals to 2, say, x squared, then the thing is that the g of x is quadratic. So the correct form of y of p remains to be the same. The general structure of quadratic is ax squared plus bx plus c. And then you solve for these constants, a, b, and c. If we have e, say, y double prime minus y prime plus y equals to 2 sine 3x, then this being a function of sine, then the correct form of yp is a linear combination of sine function and cos function. Similarly, if we had y double prime minus y prime plus y equals to, say, cos 3x, still the correct form of yp will be a cos 3x plus b sine of 3x. The thing that if we have a cos or a sine, the particular solution is a linear combination of both cosine and sine function. Now, if we have, say, y double prime minus 2y prime minus 3y equals to 4x minus 5 plus 6x e raised power 2x. Now here you have to be very careful that the right-hand side, the g of x, this is polynomial, actually which is linear. This is polynomial also, which is linear. And then this is an exponential. So remember, if we have a linear polynomial, then the correct form of yp is simply given by ax plus b. If you have a linear polynomial. So therefore, for this first part, g of x, actually we can write it as 4x minus 5 plus 6x e raised to power 2x. So let's call this one g1 of x, and then all this one g2 of x. So it's like we have x polynomial plus exponential. So the correct form of yp will be given by this being polynomial but linear. Then you'll have ax plus b, and then plus this. Remember, this is a linear function, so we'll have cx plus d, and then you multiply by e raised power 2x, exponential part. So this would be the same as ax plus b plus cx e raised power 2x plus d e raised power 2x. And then you solve for a, b, c, and d. Now, if we have g given by y double prime plus 5y prime plus 4y equals to 1 plus x squared, then clearly this g of x is quadratic. So the correct form of yp of x will be given by ax squared plus bx plus c. Then you solve for a, b, and c. H, if we have y double prime minus 5y prime plus 4y equals to sine of 3x, then this being a sine function, so the yp will be a linear combination of sine and cosine. So that's what we'll have. And if we have, say, and I remember I've said that you're trying to solve equations of this form. G of x. So the particular solution is actually determined by g of x. So assume that the homogeneous part equation do not have a solution similar to the g of x in this given differential equation. Determine the correct form of y P of x, given that g of x is given by, say, 10. So this is A. Now 10 is a constant. So the correct form of yp will be simply be given by another constant. Then you solve it. B, say g of x is given by 15x plus 10. Now 15x plus 10 is a linear polynomial, so the correct form of yp will be given by ax plus b. C, let g of x be given by 13x squared minus 20. Now 13x squared minus 20 is quadratic, so the correct form of yp will be given by ax squared plus bx plus c. Now D, let g of x be given by x cubed plus 10x plus 11. Now this is a cubic polynomial, so yp of x should take the structure ax cubed plus bx squared plus cx plus d. Please note that even if we do not have the x squared term in this g of x, provided that we have known that the highest power of x is 3 and this cubic, then you have to write all the terms which defines a cubic equation, a cubic polynomial in general. So this bx squared must be in your yp. So E, if g of x is given by sine of 5x. Now this being a sine function, then the correct form of yp is the linear combination of cosine 5x and sine of 5x. And then you solve for these unknowns, a and b. If g of x is given by 3 cos of 7x. Here, having a cosine function, then yp of x will be a linear combination of cos of 7x and sine of 7x. G, if g of x is given by e raised power 6x. Now this being exponential, then yp will take the form constant times exponential raised power 6x. H, if we have g of x equals to 3x e raised power 4x. Now here is an interesting one. It's a product of a polynomial and an exponential. And this polynomial is linear because the highest power of x is 1. So then yp will be the general form of a linear, then multiplied by e raised power 4x. I, if g of x is given by 19x minus 20, e raised power 6x. Now, this is a product of exponential and linear, so yp of x will take the form ax plus b multiplied by exponential raised power 6x. J, g of x given by x squared e raised power 2x. So this is a product of polynomial and exponential, but this polynomial is having highest power to be 2, so it's quadratic. So therefore the yp will be quadratic. We write in general form and then multiply by e raised power 2x. If g of x is given by e raised power 3x sine of 5x. Now, these are product of exponential and sine. So exponential has no problem, but the sine requires a linear combination of cosine and sine. So then yp of x will be a cos 5x plus b sine 5x, then multiply by the exponential, which reduces to a e raised power 3x cosine of 5x plus b e raised power 3x sine of 5x. Now, if we have g of x taking the form 6x squared sine of 4x. So here we have a product of polynomial and trigonometric in sine. So this will take the form polynomial general is ax squared plus bx plus c. And then for the case of this sine, we need to have a linear combination of sine and cosine. So we multiply this one by cosine of 4x plus another expression, ax squared plus fx plus g, then multiply by sine 4x. And then if our g of x is given by x e raised power 3x and then cosine of 4x. Now here we have linear, exponential, and cos. So linear is ax plus b multiplied by e raised power 3x cos of 4x plus, now same linear, but with different values, ex plus f e raised power 3x, and then sine of 4x. So those are how some of the examples to illustrate how to pick forms of yp to enable you solve the differential equations by method of undetermined coefficients. Next session, we'll do a series of examples to illustrate how to work out solution for such kind of differential equations. Thank you.